We back. We're coming at you a little bit later. We've got some footage that's a little bit greater. And we're starting things out looking at sunspots here. This is the SGO imagery. And by the way, thanks for tuning into the Smash News Network, least busted name in news. We're delighted to have you. It's just the most in-depth coverage of the sun, space weather, etc. Even some meteorology thrown in at the end. The most in-depth space weather and imagery of the sun you'll find on the internet. So we've got some sunspots up here that degraded and then re-emerged. They looked like they were going to go away, but they came back. As they approach the limb, they're more likely to produce large flares. We've got some coronal mass ejection coverage as well to show you. Also, this sunspot down here, it's got a leading umbra that's speeding away from the trailing umbra. It might be more evident here in colorized magnetogram. We do have some more active regions here rising in the east. No new sunspots as far as I know. When we did show prep, things looked pretty clear. Here's the 171 angstroms along with colorized magnetogram. And the star looking pretty lively here, despite a general reduction of solar output. Let's take a look at global seismicity briefly here. The largest quake of the past 24 was a 5.6 at Iran, adjacent to the Persian Gulf. There's a location of that quake. Looks like a fairly unpopulated area. Hopefully it didn't do too much damage. It probably did some. So we're just going to scroll up the list here. Nothing too exciting going on. It's pretty seismically calm as we see the 7 magnitude earthquake drought continue. So a 5.6 and a 5.4 happening there around the same area on the shores of the Persian Gulf there. So both of the two largest quakes happening in one spot. Indonesia also saw a 5.4. And we do see some quakes there off the coast of Oregon. Continuing on to volcanoes. And you may say volcanoes aren't space weather, but some volcanoes are space weather, like the volcanoes on Io. We'll talk about it in a moment. On Earth, we've got Karimsky erupting, producing a 10,000-foot ash plume, or a flight level 100. That's on the Kamchatka Peninsula. And also Shiveluch now appearing on the list, although satellites not identifying any volcanic ash. Semeru on East Java, Indonesia, producing a 13,000-foot plume of volcanic ash, flight level 130. And then moving down to South America, we've got Colombia, featuring Nevado del Ruiz exploding, flight level 220. It's a 22,000-foot ash plume from Nevado del Ruiz. Sangay exploding, flight level 210 from Sangay. In Ecuador, it's a 21,000-foot ash plume. And Revenador in that same nation also exploding, flight level 160. Please don't pole vault the caldera. More on that later. It's a 16,000-foot ash plume. And don't pole vault the 22,000-foot ash plume of Sabancaya in Peru as it explodes. That could be unhealthful as well. And we need you to watch the videos. So let's continue on to our regularly scheduled space weather. And here's our segue from space weather to Earth weather. The most volcanically active body in the solar system is one of Jupiter's moons, known as Io. And that moon has been known to produce volcanic ash plumes that reach out hundreds of kilometers into space. There's a great image right there of the Jupiterian moon. So let's start talking about some stars. One star in particular is the one that we'll focus on. And because, look, the reason that I'm so interested in heliophysics is because of the implications on cosmology. Folks, the reason that we think we know what's going on in the cores of distant galaxies is because of what's going on right there on the closest star. The concordance model of stellar evolution may have some holes in some theories. We'll just leave it there. So this is 304 angstroms, and we've got some additional bonus wavelengths for you today. It's our Sunday edition of the Daily Space Weather. Again, we do have coronal mass ejections and lots more to cover, so let's blast through. We don't want the video to be too long. Radio flux now down to 111 solar flux units, and the radio flux comes from the upper chromosphere and lower corona. There is the 1-year chart. It's that black line there. Radio flux now down to here, 111 solar flux units. A general downtick in solar activity. We do have a high-speed coronal hole wind stream. We'll get to the statistics on that. Space Weather Enthusiast dashboard not showing any geomagnetic unrest or geomagnetic storm conditions. We are expecting some on the 27th, early in the day on the 27th. We'll explain why later in the video. First, let's take a look at Earth's geospace. Here's our Geospace Magnetosphere movie for the past 4 hours. And again, we are seeing Earth's magnetosphere buffeted by a high-speed coronal hole wind stream. We'll get to the raw data on that momentarily, but this is a visual analysis using the space weather modeling framework of magnetohydrodynamic pressure. That was Earth's magnetic moment from space. Here's Earth's magnetic moment from the ground. Ground magnetic perturbations here scaled in nanotesla magnetic flux density, also the last 4 hours. So again, things geomagnetically calm here at the moment. I think we've only got a KP of 2, and it has to do with the magnetic field orientation not being strongly negative BZ. So here's the current situation. Planetary K-index is a measurement of global geomagnetism. KP2 is a geomagnetically calm condition. So here's our real-time solar wind data. Current situation is about 6.5 protons per cubic centimeter for the density. Solar wind speed about 526 kilometers per second. And it's just an ongoing coronal hole high-speed stream there. And let's get into the magnetic data. There are the GOES 16 and GOES 17's measurements from their geosynchronous near equatorial orbits. They are not located at Lagrange point 1 where the real-time solar wind is measured. They're located at about 10 to 12,000 miles of altitude right here around Earth. Next, looking at some imagery based on ground-based magnetometers. This GONG2 data comes from 51 ground-based magnetometers and magnetometers on stereo B out here at Lagrange 4 and stereo A out here at Lagrange point 5. Earth is in a South Pole current sheet, and we may see a North Pole current sheet coming through soon. We'll keep you posted. Here's our line of sight plot. Shows you the solar magnetogram, the sun's B field in blue. And you can see the south solar polar field actually facing Earth largely at this point. Next, we'll look at coronal holes. As solar cycle 25 continues to progress, we see south pole oriented coronal holes here in the earthly facing zone. One is fairly well defined. And here's some imagery of that from the SDO. This one up here in the north, a pretty well-defined coronal hole. Besides that, they're pretty diffuse coronal hole systems. They may become a little more defined as they face the Earth. That's the current state of affairs as far as coronal holes go. Let's move into sunspots. Mostly stable here. The leading umbra of sunspot 3065 has been speeding away from the trailing umbra. And as these sunspots here approach the limb, they're actually more likely to produce larger flares. Let's take some more imagery of the closest star here in sunspots. 1700 angstroms is a good wavelength for well-defined sunspots. That's the last 24 hours. And let's zoom in a little bit closer. You'll see these sunspots reforming here after degrading. Next, moving into solar flares. We had one happen as we did show prep. It was a C-class flare. And this flare right here is associated with a coronal mass ejection. It was a C3.4. It happened around 2230 is when peak flux began. We are expecting a coronal mass ejection strike from that. Yeah, a geo-effective coronal mass ejection. Here's some composite imagery we put together, 193 plus 94 angstroms. Since we did have some minor flaring, and let's zoom in on that view. So a few flares, mostly from the northern hemisphere, happening there in the past 24 hours. They should come through pretty well in 131 angstroms as well, so we brought that up. Made a helioviewer.org movie about that wavelength as well. That's 131 angstroms, one of the two best wavelengths to view solar flares. Again, a possible new active region rising over here. We did not see sunspots on show prep. We'll show close-up imagery of that area toward the end of the video in our bonus features segment. So let's continue on here. Plenty more information to cover. No major relativistic particle strikes. A tiny little strike right there. Not really worthy of showing up as any sort of absorption, deabsorption region issues or anything like that. No polar radio blackouts expected from such a small spike. We like to know what's going on overhead, so we show in-the-sky.org's star chart daily. It's the all-sky chart. Just put in your location. We've got Saturn setting, Jupiter pretty high in the sky, as well as Mars near the apex of the ecliptic, which is this yellow line, the path the sun will take across the sky. The blue line is the galactic plane. Let's do a solar system forecast. Keep in mind, this is not to scale. Here's your 1 week system forecast. Here's where things will be in a week. We'll have a crescent waxing moon by that point. And let's take a look at some coronagraphs. So here's yesterday. You'll see right at the end of the frames a quite significant coronal mass ejection there. Most of the material looking like it will miss Earth to the southwest. However, I believe there is an Earth-facing component in that ejecta. So here's today. We're going to show some more detailed imagery of that. The view from stereo A here at Lagrange point 5 and the Soho-Lascaux C3 here at Lagrange point 1. So we've paused this here at 2230 for the Soho-Lascaux C3, and that certainly looks like a halo. So some of that ejecta likely to strike Earth. We're expecting it to arrive early in the day on the 27th. Here's the view from stereo A, and there's some missing data there, but you can see right here come on, Epic Pen, you can do it. You can see right here there is some ejecta here, likely headed down the earthly pipeline. So that imagery combined with this imagery here, an indication that some of the ejecta is likely to be headed our way. Not this main portion, this very dense portion of mainly solar protons. That will miss Earth to the southwest, but some portion looks like it is headed toward Earth. So that imagery combined with this halo-like CME, a great example of a halo CME ejection. The more diffuse portion of that cloud may indeed be headed toward Earth. Now there was also a far side CME at the same time here. You can see from stereo A we've got this ejecta out here. And that was early in the morning today. So a series of CMEs happening there. Again, we are expecting a CME strike here at Earth early in the day on the 27th. So we've got some filaments. Once again, looking at the El Teide, Spain ground-based hydrogen alpha observatory. And lots of filaments in the earthly zone here. You can see all these dark regions. Those are all absorption features known as filaments. Some of them could eject. It's kind of likely. And yeah, remember folks, you don't need solar flares, or sunspots to see coronal mass ejections. Moving on to the GOES 16 SUVI, again, we did just see a C-class flare. It should show up on this imagery. This is the last about 2.5 hours. And I think that flare was from this region right here. Again, flares more likely as those sunspots approach the limb. Also a prominence down here at the south solar polar region. And one right there. Here's some additional imagery. This is the last 24 hours. In 171 angstroms, the house favorite. Just spectacular. And we've even added 304 angstroms to this view. There's 304 ionized helium plus 171 ionized iron. The sun called. It left us a voicemail, and it said, "I am Iron Star." So here's our bonus feature segment. We will show the total electron content, the ionosphere, and more, as we do most days lately here at the Smash News Network. Least busted name in news. So here's your total electron content forecast. It's the coupled thermosphere, ionosphere, plasmasphere electrodynamics model. It'll show you the most likely places for GPS errors. Your GPS satellite's located at a very high altitude, over 12,000 miles of altitude. And if it communicates through a lot of free electrons, you'll have a huge signal refraction. Feel free to pause the frame on that. Feel free to pause the video on that frame. Next, looking at charging hazards here for satellites. Only some minor surface charging hazards here caused by low energy electrons. Nothing to write home about, unlikely to produce any major communications errors. Let's continue on. Here's the GOES electron flux over the past 3 days. And fairly high levels of electron flux considering we have this ongoing coronal hole high-speed stream, as well as a coronal mass ejection a couple days ago. So fairly high levels of electron flux considering how many protons have been arriving at such high speeds. NOAA forecasting an increase in the electron flux, and I would tend to agree there after the coronal hole wind stream subsides that we would indeed see an increase in the electron flux. It's typically what we would see happen. Here's the one-year chart from Solon.info of the greater than 2 mega electron volt electron fluence. Next, we'll show the F ionosphere layer, the bridge between Earth and space, located at about 300 kilometers of altitude. Here's the vibrational frequency. And if you think CERN is doing that, I don't know why you would think such a ridiculous thing. CERN is not affecting the ionosphere. But anyway, that's what's going on. And we do see some anomalies here. We'll show the anomaly gram as well, since it may not be evident. Showing some uncommon footage here. I've yet to see a space weather channel show any ionosphere data. This is the anomaly in megahertz from the 30-day median. We are seeing some high and low frequency anomalies there. High in blue, low in red. Here's the latest image. It's from 10:45 Universal Time. And for some reason, we've got an 11 o'clock Universal Time anomaly gram. Moving on, to remind you that this video was originally streamed live to Twitch. We use Twitch regularly to stream live here at the Smash News Network, least busted name in news, because, well, the platform is so good. Speaking of good, we've created our own web ring because of pathetic censorship in 2018. In 2019, a crack YouTube unit, not a crap YouTube unit, a crack YouTube unit, was sent to social media prison for a crime we did not commit. We promptly escaped a maximum security social media stockade to the internet underground, where we survive as producers of fortune. If you have a problem, like nonsense on the internet, maybe nonsense about the sun and space weather and so on. If you have a problem, if no one else can help, and if you can find the content, maybe you can hire the Smash Team. There's our Smash Team posts page. Thanks to our gold and silver subscribers, if you want to support the channel via subscription services, become a gold or silver subscriber. You'll get additional information. And even if not, welcome to the Neo Renaissance. Congratulations on realizing the channel exists. We just keep putting up facts, regardless of how much nonsense you might find on certain platforms. We would remind you to not pole vault the caldera, as our finest days lie ahead. Yeah, our finest days lie ahead, folks. I'm not just saying it. I really believe it. So, things will look up, no matter how many idiotic decisions get made. Eventually, accountability will always come. Accountability always comes. So don't pole vault the caldera. It could be unhealthful. We don't want you to become part of a lava lake. And we don't want to breathe you in because we're downwind from said lava lake. So don't pole vault the caldera. Our finest days lie ahead. And these are some fine graphics printed onto these products. So check them out if you want something tangible. To help us out, give Smash staff a raise. She desperately needs one. As we pay her just about nothing, since we're paid just about nothing to make these videos, and she is a partner. So, thanks to our YouTube subscribers, the few of you who exist, please press the notification bell. Maybe press share if you're a larger channel. Invite us on. We'll be more than happy to appear on your channel and feature you on ours. Moving into the latest high-resolution imagery of the closest star. There's the latest intensitygram, and there's the latest colorized magnetogram. We do have an active region showing up down here, and it is not yet a sunspot. Once again, these sunspots here that are setting toward the western limb, they're more likely to produce large flares as they set. The three most magnetically complex groups are this one here, and this one here. They're all beta-gamma class sunspots. And let's bring up a composite series of images here from SDO to close out our space weather portion of the video. We will move into the realm of meteorology. As I became a master of meteorology about 15 years ago, I realized that I needed to expand into something more difficult. And again, the reason that I study heliophysics is because of the implications on cosmology. Yeah, there are implications. Anyway, that's yesterday and today from the closest star. And next up is our meteorology segment. So we shall start things out by heading to nullschool.net. Now, we've been recently featuring the Saharan dust blowing across the Atlantic Ocean. So there's the current state of affairs for that. Quite a bit of Saharan dust here making its way into the eastern Caribbean. And let's take a look at, let's take a look at waves today. How about that? Let's take a look at waves, and we'll look at significant wave height. If you're wondering where the hottest surf is, well, it's around the Antarctican sea ice. There's probably no break at the Antarctican sea ice. Anyway, because remember, folks, the water has to get more shallow for waves to break. Australia looking like it's having some pretty decent waves there on its west coast. Otherwise, maybe some quality California waves there as well. Back to our regularly scheduled programming here. It's the surface winds of the land Fremunda, and the most populous portion of the planet, which is right about here. There's like 3 billion people in that area. And we've got a strong low here off of the northwestern coast of the North Island of New Zealand. So here are the jet streams of this side of the planet. Very chaotic jet stream in the northern hemisphere. Here are the jet streams of the Americas. And the jet stream, once again, mostly staying north of the U.S. We've got, once again, a high-pressure system right here over the center of the country. It's rotating clockwise as high-pressure anticyclonic systems do in the northern hemisphere. Convective forces largely at work. It's a heat dome. Here are the surface winds of the Americas. Here are the surface winds of the central world, Europe, Africa, and the Middle East. We've got a strong surface low here around Ireland and Scotland. You can see a counterclockwise rotation happening right there. Here are the jet streams. Is there any influence? Not so much. Jet stream blowing backwards here over the Indian Ocean and portions of Africa. As you can see, the jet stream here reversed from its normal mode. It's blowing east to west. Continuing on, here's your weather.gov map and lots of heat advisories and some flood advisories in Colorado, New Mexico, even portions of Kansas, and a large portion of southern Arizona. Some warnings there for Alaska as well, like gale warnings, it looks like, and also some gale warnings around Hawaii. If your county's lit, head to weather.gov and click your county. We were expecting triple digits here in Pennsylvania. We'll have to look at that later. First, your lightning mapper. There's your NASA GOES lightning mapper and some heavy lightning here moving across the Great Lakes region. How about a real-time lightning map to see what's going on now? Do we have terrestrial strikes? And indeed we do. Detroit. It looks like you may be out of the crosshairs at the moment. We've got some small cells here around Peoria. Some thunder rolling in there, some minor lightning strikes there around northwestern Peoria. Anyway, we'll zoom back out. Some lightning there on the north coast of Lake Erie. Also some lightning east of Phoenix. Anyway, that's your real-time lightning map from lightningmaps.org, powered by blitzertung.org. And Russia getting some serious lightning. Leave us a comment if you think Putin is creating the lightning. Do you think Putin's creating the lightning and inflation and all kinds of other... Do you think Putin is doing things that Putin is incapable of doing? We want to know at the Smash News Network, least busted name in news. So leave us a comment and tell us all about it. Next, we've got a weather forecast here. Here's your pressure and precipitation forecast based on the GFS model for the lower 48. That's a 72-hour forecast. Since 3-day forecasts tend to be accurate, there's where you can expect weather systems to be over the next 3. And here's the pressure environment. We've got an anticyclone over the North Pacific, a low pressure system here encompassing southern Alaska and the Aleutians, the Alaskan Peninsula and the Aleutian Islands. And again, you can see that strong low here around Scotland. Scotland and Ireland there, featuring an oblong-shaped low pressure. Continuing on, here's your temperature anomaly forecast. Keep in mind, temperatures are shown here in degrees Celsius. This is the GFS model for the next 72 hours. And you can see some huge swings in temperature happening there, switching from low to high and vice versa. Again, expecting some quite hot weather today in Pennsylvania. Hey, Smash staff, are we still expecting triple digits in Pennsylvania today? She says yes. Anyway, once again, that's your 72-hour temperature anomaly forecast based on the GFS model. Next, we've got your weather.gov radar map. There is the full 50 states view. We're going to focus on the lower 48 for the remainder of the video. Let me just press refresh there as it's not animated because reasons. There we go. Huge band of moisture there moving from Chicago toward Rochester. Hey, Buffalo, you're in the crosshairs as well. And we're just going to ignore that because it's not animated. Here is our shortwave radiation map showing 3.9 nanometer infrared radiation from the NASA GOES Interactive Weather Satellite Suite. And there is the water vapor. You can see that moisture being sandwiched in between jet stream pushed dry massive air. This is a relative high pressure system. This is a relative low pressure system. And it's butting up against this dry massive air, creating massive pressure gradients. There's a huge temperature gradient as well happening there. Here's your recap, the U.S. Doppler radar showing vertical motion of water droplets in the air column. Here is your satellite imagery showing clouds and fog. And here is your water vapor satellite. Hey, everybody. Thanks for tuning into the Smash News Network, Least Busted Name and News. Thanks for leaving a comment, General Disturbance, who says, Putin is just a mafia boss with an overextended ego. Oligarchs are oligarchs, and oligarchs got a oligarch. Anyway, we'll see you soon at the Smash News Network, Least Busted Name and News. Thanks again for tuning in to the comprehensive Sunday edition of our space weather and meteorology content. As I sign off, I'm Smash-O-Mash, by the way, a.k.a. Dan Nigro. And may that solar wind be at your back.